right, welcome. I'm Mr. Anderson, and this is your Chapter 1.6 homework help. I'll try to make this just a quick 10-minute video to help you with your homework. And I've chosen these problems right here, similar to your homework problems. I'm going to go through pretty fast, but here you have the opportunity to pause me and see what I did. Maybe rewind if I did it too quickly. Okay, let's take a look at number 5 here. X is less than or equal to negative 5. All right, here's negative 5, less than or equal to. So we need this dot and we need to fill it in to denote that it can be equal to negative 5 as well. And then X can also be less than that. So less than or equal to negative 5. All right, number 7. 6 is greater than or equal to X. Well, let's plug in 6. I don't quite have my number line long enough here. 6 would be right about there. And we've got a greater than or equal to right now. And 6 is greater than or equal to X. So 6 is the most that X can be. So we're going to be including these numbers. We can put X on the left side if we want to, but remember we have to switch the symbol around if we move X to the other side. So this symbol still has to be pointing to X. So we'd have X is less than or equal to 6. It's kind of like we just spun it around and this sign spun around too and point the other direction. So we have X is less than or equal to 6. They're both saying the same thing. All right, so less than or equal to, we have to fill in the dot, denoting that it can be equal to it. And we have everything that is less than that number as well. Okay, number 9. We have X is greater than or equal to negative 3.5. Let's see, negative 2, negative 3, negative 4. So right in between negative 3 and negative 4, we'd have negative 3.5. Greater than or equal to, so it'd have to be a filled in dot again. And everything that is bigger than negative 3.5 as well. So we'd have a arrow pointing this direction. And take note also that notice that our inequality signs are pointing the same direction as our graphs when X is on the left side. So here we've got our inequality sign pointing to the left. Our graph is also pointing to the left. Here we had to put X on the left side in order for that to follow our graph, the inequality sign to follow our graph. But when we put it on the left side, then it did follow our graph here. And then here as well, we see the inequality signs pointing to the right and our graph points to the right. You might want to take note of that as well. Okay, let's move along to problem number 13. Okay, we are told here, write the compound inequality that is represented by the graph. Okay, well, we have a negative 2 here. Negative 2, and negative 2 is not included, but it's everything less than 2. So we have X is less than negative 2, and then we have to have an or everything that is greater than 4, and 4 is not included. So we have X is greater than 4. And notice we have to have an or here. We can't have X both smaller than negative 2 and greater than 4 at the same time. We have to have this this or here, and just separate the two inequalities. All right, let's take a look at the next problem. 17. Let's see what we're told. Graph the compound inequality. All right, so here X is larger than negative 3. See, it's opening up to X. The alligator is eating the larger number, so X is larger than negative 3. Let's find negative 3 right there in between. I only put the even numbers. And it is not including negative 3, so we have an open circle. And also x is less than 4. So again, we have to have an open circle, and it's going to be everything in between. So x is both greater than negative 3, and it's less than 4. All right, let's take a look at 21. We have x is greater than negative 2. Here's negative 2. X is greater than negative 2, so not including negative 2, but everything that's greater than that. Or x is less than negative 5. Well, here's negative 5. We have to have an open circle again because we are not including negative 5, and it's everything that is less than that. Let's move on to number 28, and we are told to solve the inequality, then graph the solution. All right, and remember that if we are going to divide by a negative number, we need to flip the sign, or if we're going to multiply by a negative number, we need to flip the sign. Also, as we saw in problem number 6, if we put the variable on the other side, we need to flip the sign as well. Let's see how this turns out. All right, we have 2x minus 6 is greater than 3 minus x. Well, we want to get all the these numbers on one side and all the x's on the other side. So let's do that just as if this was an equation, but it's an inequality. We want to add 6 to both sides to cancel that out. Kind of move it over here. All right, and then at the same time, let's get this x over here. We have a negative x minus x, so we want to add x to both sides. That will cancel this x out over here and add it over here. Let's see what we end up with. 2x plus x is 3x's. Negative 6 plus 6, that cancels out. That's why we did it, is greater than 3 plus 6 is 9. Negative x plus x, well, that cancels out. That's why we did that. And then now we have to divide by 3 because we have 3 times x. So we have to divide by 3 in order to get rid of that coefficient of 3. And we have to do the same thing to both sides of the equation. We don't flip our sign because we did not divide by a negative number. We divided by a positive number. So we don't flip our sign. 3 over 3 is just 1. And 9 over 3, or 9 divided by 3, is 3, or 3 over 1. Okay, let's clean this up a little bit. 1 times the x is just x is greater than 3. All right, let's graph our solution now. All right, I'll graph this one in red. Okay, x is greater than 3. 3 is right here. We have an open circle denoting that we do not include 3, but only everything that is greater than 3. Okay, let's take a look at the next one. Oh, compound inequality. All right, now remember we have to do the same to the entire inequality. When we add or subtract or divide or multiply, we have to do it to all parts of the inequality. So here we want to, we've got 3x minus 1, and it jumps out at us, hey, let's move this, this 1. We want to get x all by itself. We have to do it to all parts of the inequality. So we have to do it over on this side of the inequality. We have to do it over here as well. We have to do it to all parts. So let's clean this up. We've got 2 plus 1 is 3, which is less than 3x. This cancels out. That's why we did it. which is less than or equal to 6 plus 1 is 7. Now we have to divide by 3. We have 3 times x, so we have to divide by 3. And we have to do that to all parts of the inequality. Clean this up. 3 over 3 is 1. 3 over 3 again is 1. And then we have 7/3. Let's clean it up a little bit. We've got 1 is less than 1 times x is just x. And is less than or equal to 7/3. We'll just leave that like it is there. Okay, 7/3. Okay, we can put that into a mixed fraction. Let's see, 3 times 2 is 6, and then we just have 1/3 left over, so we could also call that 2 1/3. Or if we plug it into our calculator, 7 divided by 3 is also 2.33 repeating. All right, I'm going to graph this one in blue. Okay, let's find 2 1/3. We got to go 1/3 the way from 2 to 3, so right about, let's say right about there is 2 1/3. Okay, and we have a, it can be 2 1/3, so we have to have a filled in dot there. And our other one is at 1, but it has to be, x has to be greater than that 1. All right, so x is greater than 1 and also less than 2 1/3 or 7/3 there. So everything in between there. All right, let's move on. Our last 2 problems here. We are asked to, in 45, let's see, we are asked to solve the inequality, then graph the solution. Okay, let's take a look. First, let's move this over to the other side. So we have to add 3 to both sides of the inequality. You got to do the same thing to both sides. Now, we know how to solve this, and we know how to solve this. All right, so we just solve them separately. You can go along and solve them simultaneously, or we can go down and solve this one and then solve this one, and we just continue on down the line, or. Let's clean this up. What we've got is 2x, that cancels out, is less than or equal to minus 4 plus 3 gives us a minus 1. Now we have to divide by 2. So we don't flip the sign because we are dividing by a positive number. We'd only flip the sign if we are dividing by a negative number or multiplying by a negative number or moving the variable to the other side of the equation or the other side of the inequality. All right, 2 over 2 is just 1, and then we have negative 1/2. So let's clean this up a bit. We have x is less than or equal to negative 1/2. All right, or let's solve this side of it. 3x plus 1 is greater than or equal to 4, so we want to subtract off 1 off both sides of the inequality to get that to cancel out. We'll end up with 3x, that cancels out. It is greater than or equal to 4 minus 1 is 3. All right, next we're going to divide by 3. Again, we don't flip the sign because we are dividing by a positive number. 3 over 3 is 1, and 3 over 3 here is also 1. Let's clean it up. We have x is greater than or equal to 1. All right, so let's graph this whole thing here. Let's graph the whole thing that we have here. I'm going to graph it in blue. All right, so x is less than or equal to negative 1/2. Well, here's negative 1. So right between the 0 and the 1 would be negative 1/2. Negative 1/2. We have to have a filled in dot. and it's everything also that's less than that. So it's going to look like that. And then over here we have x is greater than, or x is greater than 1. Here's 1. Again, a filled in dot to denote that we can have it equal to 1 as well. All right, and then everything that's greater than that. All right, let's look at our final problem here, number 39. Okay, another compound inequality. And we are told in 39, solve the inequality, then graph the solution. All right, so see here, we want to get rid of this 4 in order to get x all by itself. So let's subtract off the 4. We have to do it to all parts of the inequality. -3 minus another 4 gives us -7. That cancels out. That's why we did it. And keep the sign. Less than. Notice we don't flip the sign. We're just subtracting off 4 off of both sides. Is less than -x. Is less than or equal to 3 minus 4 gives us a -1. All right, now we have a -x, and we got to get rid of that negative. So we're going to divide, or we can multiply all sides by a -1. -1. Okay, let's clean it up. -7 divided by a -1 is 7. And here we divided by a negative number, so we're going to have to flip this sign here. We got to flip that sign to a greater than. Negative over a negative, that's going to give us the x. That's why we did it. Is greater than or equal to, we got to flip the sign again because we divided by a negative number. And that -1 over -1 is just 1. So let's graph this one. Let's graph this in red here. No, let's graph it in red. Graphing this right here in red. Okay. So x has to be less than 7. I guess I didn't have 7 on here. 7 would be about right here. Has to be less than, so it is denoted by an open circle. And x is also greater than or equal to 1. All right, filled in circle to denote that it can be equal to that. And it's everything in between there. So we see that x is less than 7 and greater than or equal to 1. All right, thanks for watching, and I will see you in class.